Carbohydrates, part third. In this part, we will see chain lengthening and chain shortening of aldoses. So, chain lengthening of aldoses, lengthening means to increase the length. The reaction of chain lengthening of aldoses is known as Kiliani synthesis. The method for increasing the chain of aldose by one carbon, that is conversion of aldose to next higher aldose. For example, aldopentose to aldohexose or aldohexose to aldoheptose, that is known as Kiliani synthesis. For example, conversion of aldopentose containing 5 carbon atoms into aldohexose containing 6 carbon atoms. Following steps are involved in the conversion of aldopentose to aldohexose. So steps are, first step is formation of cyanohydrine. Aldopentose on reaction with HCN forms cyanohydrine. This process introduces new chiral center. Hence, it forms a mixture of two diastereoisomers. These differ only in the configuration of newly introduced chiral center, that is C2. And these two are known as epimers. The step second is hydrolysis of CN group. Cyanohydrine on hydrolysis by BaOH twice followed by acidification with sulfuric acid gives aldonic acid. And step third, conversion of aldonic acid to lactone. Aldonic acid on heating forms lactone. And the last step, that is step fourth, that is reduction of lactone. The gamma lactone on reduction by sodium amalgam NaHG gives next higher aldohexose. That is next higher aldose containing one carbon more aldohexose. So this is the reaction sequence. First, we start with aldopentose reaction with HCN, formation of cyanohydrine takes place, and here one carbon is added, and this is the carbon which is introduced in the molecule. So up till here the structure is all these one, two, three, four, 5 carbon atoms are already there, but this is the new carbon of Cn. So formation of cyanohydrine by reaction with hydrogen cyanide. This cyanohydrine further reaction with BaOH twice barium hydroxide hydrolysis takes place, and reaction with H2SO4 we get aldonic acid. Here, conversion of this Cn into aldonic acid takes place, that is Cn to COOH. This carboxylic acid group is formed by Cn group. And there, further dehydration takes place and we get the cyclic compound, that is gamma lactone. This gamma lactone, upon reduction with sodium amalgam, that is NaHG, we get aldohexose. What happened here? Reduction of gamma lactone takes place and conversion of this gamma lactone to this carbonyl converts into aldehydic carbonyl, and this is the extra or additional carbon in the product. So we have started from aldopentose and ended up with aldohexose. Thus, Kiliani synthesis The overall change is the creation of asymmetric center. This is the asymmetric center. Asymmetric center is the center to which all four carbon atoms, all four groups to that carbon are different. That is known as asymmetric center or chiral center. Thus, it results in the formation of two higher aldoses differing only in the configuration at C2. So, two compounds are formed, and these are epimers. They differ only in the configuration at C2. Then next reaction is chain shortening of aldoses. Exactly reverse of the Kiliani synthesis. In Kiliani synthesis, we have increased the length by one carbon, but in this chain shortening of aldoses, we decrease the length of chain of aldoses by one carbon, and this reaction is known as Weerman reaction. Aldose chain can be shortened by one carbon from aldehyde and by Weerman reaction. Weerman's reaction is useful for the conversion of aldoses to lower aldoses containing one carbon atom less than the starting aldoses. In this method, alpha hydroxyamide is degraded by the reaction with sodium hypochlorite. For example, conversion of aldohexose to aldopentose. Aldohexose contain 6 carbon atoms and aldopentose contain 5 carbon atoms. In this method, aldohexose, that is D-glucose, is oxidized by mild oxidizing agent bromine water to the aldonic acid, that is gluconic acid. Aldonic acid is converted to corresponding alpha hydroxyamide. It on degradation by means of cold solution of sodium hypochlorite NaOCl gives isocyanate, and this isocyanate in presence of alkali forms aldopentose. The reaction proceeds as shown here. First of all, aldohexose is oxidized with bromine water and we get aldonic acid. What happened here? This aldehyde have been converted into COOH group, and after oxidation we get aldonic acid. This aldonic acid on reaction with ammonia we get alpha hydroxyamide. This COOH have been converted into CONH2. All remaining structures is same, only change is conversion of COOH into CONH2. Then further, this alpha hydroxyamide on reaction with sodium hypochlorite, we get isocyanate. And here, only the change is this amide have been converted into isocyanate. Isocyanate upon reaction with sodium hydroxide, there is degradation of molecule and a removal of sodium isocyanate takes place. Here, sodium isocyanate is eliminated and here one carbon is lost. And finally, we get product with 1, 2, 3, 4 and 5 carbon atoms. That is aldopentose. We have started with aldohexose containing 6 carbon atoms and ended up with aldopentose with 5 carbon atoms. That means we have converted the reactant into product containing 1 carbon less. This reaction is similar to Hofmann degradation. So this is the method known as Weerman's reaction. Thank you.